Hey guys, welcome back to Fibonacci. In this video I'm just going to solve Aggarwal's book solutions, I mean ICSE Mathematics. So this is a textbook called Understanding ICSE Mathematics by Aggarwal for the ICSE students in India. So I'm just going to solve the problems in that textbook. So if you are an ICSE student, you just can subscribe to this channel. So let's get into the video. So first chapter is trigonometry. So I have chosen trigonometry is considered to be one of the toughest subjects ever by the students because it deals with some kind of sine, cos, tan and etc. So students feel so difficulty to handle trigonometry. So I just have chosen trigonometry to solve you at the first time. So I have chosen the topic trigonometric identities. This is what the chapter name. So and this is what the exercise, and I have took 3 problems in that, and I'm just going to solve it for you. So let's get into the video. So now let's get into the question. If A is an acute angle and sin A equal to 3/5, so they have given that A is an acute angle. So for trigonometry we always deal with the right angle triangle. So I just have drawn a right angle triangle and I'm just going to name the angle as A. So for A is an acute angle, this is an acute angle, and sin A is equal to 3/5. So where sin A is a trigonometric function of angle A, which is equal to 3/5. Now the question is find all other trigonometric ratios of angle A. So now we should find all other trigonometric ratios of angle A. Okay, let's find it. So before getting into the video, I'll just like to give some formulas to you. That is the trigonometric ratios. Sin A is nothing but opposite divided by hypotenuse. Cos A is nothing but adjacent side divided by hypotenuse, and tan A is equal to opposite divided by adjacent. So these are the 3 fundamental ratios, and we have the inverse of these ratios too. So I'll just introduce them too. So the inverse of sine is given by cosecant A, which is inverse of sin A. So sin A is given as opposite by hypotenuse, so we have to invert it to get the cosecant A. So it's simply hypotenuse by opposite, and cos A is the inverse of secant A. Secant A is hypotenuse by adjacent, and tan A, and we have cot A. Cot A is the inverse of tan A, so the formula for that will also be given as adjacent by opposite. So these are the 6 fundamental ratios that we have to we are just going to use in this problem. So this is very fundamental formula that you have to remember. So now let's get into the actual problem. They have given that sin A is equal to 3/5. Alright, so comparing it with the formula of sin A is equal to opposite divided by hypotenuse. So by comparison we can get that opposite is equal to 3 and hypotenuse is equal to 5, right? So in this triangle, in this right angle triangle, if you consider the sides, this particular side is known as hypotenuse, and this particular side is known as opposite, and this side is known as adjacent side. So we just have to replace the value according to the side respectively. So opposite is 3, right? So the opposite side value is 3 and hypotenuse is 5, and we don't know the value of adjacent. So now I'm just going to tell you the trick to find the value of adjacent. So in a right angle triangle we can use Pythagoras theorem. The Pythagoras theorem actually states that hypotenuse square is equal to opposite square plus adjacent square. So hypotenuse square, which is simply 5 square, which is equal to opposite square plus adjacent square. So what's the value of adjacent? We don't know the value of adjacent, right? So let it be like that. So adjacent square. So 5 square is equal to the value of opposite is simply 3 square plus adjacent square. I'm just simply writing it as A square. So from this we can write A square is equal to 5 square minus 3 square, that is 25 minus 9, and this is given by 16. So A square is equal to 16 and A is equal to the square root of 16. So A is simply 4. So the adjacent side is 4. That's it, right? Okay, now we're just going to find other trigonometric ratios, because we got the value of opposite, hypotenuse and adjacent, right? So here adjacent is simply 4. So now Sin A is equal to opposite by hypotenuse, that is opposite side divided by hypotenuse, and cos A is equal to adjacent divided by hypotenuse. Adjacent side is given by 4 divided by 5, and tan A is given by opposite divided by adjacent, and the opposite side is 3, adjacent side is 4, 3 over 4. From this we can find the values of cosecant, secant and cot easily, because cosecant, secant and cot are the inverses of these three functions respectively. So cosecant A is the inverse of sine, so we just have to invert this value, that is 5 over 3, and secant A is the inverse of this particular value, this particular function, that is we have to invert this value, that is 5 over 4, and cot A is the inverse of tan A, and we have to invert this is simply 4 over 3. So these are the trigonometric values that they are asking. So let's move to the next question. Hope you understand this problem. So I'm just moving to the next question. The next question is also same. If A is an acute angle, so for trigonometry we should always deal with right angle triangle. So I'm just drawing a right angle triangle. So if A is an acute angle, they have given that A is an acute angle, so I'm just going to write this A here, and secant A is 17 by 8, right? So the formula for secant A is nothing but hypotenuse side divided by adjacent side, so it's simply the inverse of cos. So here hypotenuse is 17 and adjacent side is 8, and we don't know the value of opposite side. Now I'm just going to find the value of opposite side. So from Pythagoras theorem we have that hypotenuse square is equal to opposite square plus adjacent square. So hypotenuse square 17 square is equal to opposite square plus adjacent square is 8 square. 17 square is 289 equal to opposite square plus 64. Now I'm just going to bring it to the left hand side to get the value of opposite square. It's simply 289 minus 64. If you subtract it, you will be getting 225. So opposite square is 225. Taking square root on both sides, you will be getting the value of opposite as 15. So this is what the value. So the value of opposite is 15. So now what I'm just going to do is I'm going to find the trigonometric ratios of this particular triangle. So now I'm just going to find sin A is equal to opposite by hypotenuse, which is nothing but 15 by 17. Cos A is equal to adjacent by hypotenuse, which is nothing but 8 by 17, and tan A is equal to, what's that, opposite divided by adjacent, which is nothing but opposite is 15 and adjacent is 8. So these are the three fundamental ratios, and we have cosecant A. Cosecant A equal to the inverse of sine, so we have to invert this, that is nothing but 17 by 15, and secant A is equal to the inverse of cos, so we have to invert this, this is 17 by 8, and tan A is the inverse of, cot A is the inverse of tan A, so we have to invert this, so it's 8 over 15. So that's it. This is a very simple question. So let's move to the next problem. I hope you understand this problem. So I'm just moving to the next problem. The next problem is, if 12 cosecant theta equal to 13, then we supposed to find the value of this expression. So they have given that 12 cosecant theta equal to 13. From this, so these two terms are in multiplication, so we can write it as cosecant theta equal to 13 by 12. So as I already told you, trigonometry always deals with right angle triangle. So I'm just going to draw a right angle triangle here. This is a right angle triangle, so I'm just going to write the side names, or hypotenuse, adjacent, and this is opposite. This is some angle theta, that's it. So the formula for cosecant is hypotenuse divided by opposite. So the value of hypotenuse is nothing but 13 and opposite is 12. Now I'm just going to find the value of adjacent, the length of adjacent, by using Pythagoras theorem. That's nothing but hypotenuse square is equal to opposite square plus adjacent square. So hypotenuse square is 13 square is equal to 12 square plus this is adjacent square. right? So 13 square is given by 169, which is equal to 12 square is 144 plus adjacent square, so which is nothing but 169 minus 144 equal to adjacent square. This is simply 25 equal to adjacent square. So taking square root on both sides, you will be having adjacent side is equal to 5. So I have found, so now we have the values of the sides of this right angle triangle. Now what I'm just going to do is I'm just going to find the value of this particular expression. So we have 2 sine theta. So the sine theta is given by as the ratio of opposite and hypotenuse. So here the opposite value is 12 divided by hypotenuse is 13 minus 3 times cos theta. Cos theta is given by adjacent divided by hypotenuse. Adjacent side is 5 and hypotenuse is 12. The whole divided by 4 sine theta, which is 4 times sine theta is the same, 12 by 13, and minus 9 times cos theta is also same, that is nothing but 5 by 13. Here it's 13, it's not 12, 5 by 13 because hypotenuse is 13. Now what I'm just going to do is simplify. I'm just going to simplify this. Just look at the simplification. So multiply this number with the fraction. 2 times 12 is 24 by 13 minus 3 times 5 is 15 by 13 divided by 4 times 12 is 48 by 13 minus 9 times 5 is 45 by 13, which is given with the denominator same in the numerator and the denominator. So we just can combine that. 24 minus 15 by 13 divided by 48 minus 45 by 13. So here you can cancel out these two values, 13 and 13. Then you will be having 24 minus 15 is nothing but 5, it's nothing but 9, and 48 minus 45 is 3. So you just cancel it out. So then you will be having 9 over 3, which is simply 3 times 3 is 9, so 3. Hence the value of this particular expression is 3. So if you have any doubt, you just leave it in the comment. I'll just share the solution or the easy method for you to understand. Hope you like the video. Please do like, share and subscribe. Share it with your friends. Thank you.